Hello everyone, welcome to the session on sketch-based features. At the end of this session, you will be able to learn the commands like pad, pocket, shaft, and groove. So let us discuss the first command, that is pad. So I'm switching to the software, click start, mechanical design, part design, give the file name, click OK, hide this all planes, insert one axis system, add different planes, this is not mandatory to create the planes, just I'm creating for the explaining the pad tool. I'm creating multiple planes. Now click on sketch, select this top plane, create a profile, create a rectangle. Now select here the tool from sketch based features toolbar, first tool, which is pad. Now once you click on pad, you will be finding this dialog box. In this dialog box we have various set of options. So in the first limit you will be finding various types, dimensions, up to next, up to last, up to plane, up to surface. Then in the dimensions, if you select, then you can define the specific dimension through length. Then in the profile or surface option, you can able to select the profile or surface to add a material to the selected sketch. You can apply the thickness or you can make a symmetric material addition. Let us see it one by one. So I select here dimension type and I'm giving this length, that is the height of model is 30, and here you have to select this profile. Now as compared to this height of your planes, the 30 is much more. I'm taking this value to 15. Accordingly you can modify this. If you click on preview, you can able to see this 3D display. After that, to see these different options, I'm using this various planes. So here I'm defining this front view orientation. To see this better effect, I'm aligning this object into front orientation. Now here you can change this value to 20. If you want to reverse it, you can use this direction reversion. Here you can reverse this direction. This is 15 I am taking. If you use mirror extend, then the material will be added symmetrically. So the total distance become 30. If you provide here value 15, so it will double the value. If you switch off this, this mirror effect will reduce. So here you can see mirror extend, and you can increase this first limit. Automatically second limit is also updating. I can switch off this mirror extend. To make it unsymmetric distance, you simply go to the move option. In the more, you can see the second limit. Here you can define the second limit, which is 10. See this preview. So first limit is 22, second one is 10. So this is unsymmetric value. But if you hit mirror extend, so it will be symmetric material addition. If you switch off this button and use the second limit option, its value is 10, or you can take any value. So it is unsymmetric distance. If you don't want the second limit, you can provide this value to 0 and use this option less. Say this preview. Slowly rotate your mouse and you can see this effect. Now here I am taking this value 15 only. Then click enter. After that, select another sketch, create here another sketch, select this plane, then you can orient this absolute axis, then create here circle, define the diameter of circle, (15). Then exit this workbench. Then add the material to it. Select this pad, select this sketch, this value I'm taking here 20, click OK. I'm selecting this plane again and draw the sketch using sketcher tool, then click OK. Create a profile, circle, define the diameter, let's suppose it is 8, click on exit workbench, add material, use the option here up to plane, which is this one. Say this preview, and in the second limit option I want to extend this profile up to this face. So here you can define up to next option, click on OK. So up to plane, up to next, this we have discussed. Now here if I'm creating another plane and I'm trying to create a profile on this top plane, this diameter is larger than previous, it is 10.5. Click on exit workbench, again here I'm creating the sketch, with larger diameter, it's 22. 22 diameter circle. Now I need to add a material using pad for this smaller circle, and I need to add the material to this circle up to the last feature. So I don't have this last feature over here. So before doing that pad, I'm creating one feature over here, then click OK, and now you try to create a pad for this circle, and now you see here you can drag this first limit, and now you can see here up to last feature. This feature will be extended up to the last limit of the face. So this is up to last, and if you use up to next and you see this preview, use up to next and see this preview, it will add material up to this surface only. Okay, so here I'm trying to reduce this diameter to 6 so that both effect you can able to see clearly. Just click on pad, select the first profile, and now use the tool up to next. I'll change this value to 9. Now you try to add material. You can see here up to next, the material will be added up to this surface. If you use up to last, the material will be added to the last feature. So whatever the immediate next surface getting to the software, so that will be considered the next surface. Now here I am taking this dimension, then click on OK. So this modify, you can able to modify these dimensions to 30. So these are the various options in the pad. So I already created another example to understand this. Here I create circular profile as a base profile, define this diameter to 50, add a material to it using pad tool. This value I'm taking here 10, click OK. So it is circular disc is created. The second feature I required here, so I create a profile first. This diameter is 24, click on exit, add material to it. This height is 25. Now third profile I'm creating here. This diameter is 12. I'm going to create a sketch. Create a circle with the diameter value 15. I need to add a material up to next surface. So select here pad, direction reverse, use up to next option. If you use up to last, software not getting immediate surface to the last size. So here to get the result, I need to modify this diameter with larger value. So instead of 12, I'm taking value to 28. Click OK. So diameter is increased. And now you try to create a material addition to this profile. And here I'm taking this value up to next. If you use this value up to last, now it will be reached material to the last feature of the surface. And if you use up to plane, you can select here this plane, or you can able to select limit using up to surface. So here you can select the surface manually up to this surface only. You can see here manually you can able to select this surface. Up to this surface material will get added. And if you use up to plane, you can take this plane. If you modify this and you try to use this second side limit as 25, then bottom side as well the material is added. Now to provide the thickness to this object, you can use the tool thick, and you can see here the thickness how much you want. Let's suppose it is 0.5, and see this preview, you will get the thicker object. The thickness of feature is 0.5. Second limit thickness you can define here 2. So inside it is 0.5 and outside thickness is 2. You can see this, and if you use this neutral fiber, it becomes symmetric to the center. To see this effect, I am just aligning this orientation to the top view, and now you can see this in better way. So this center is our sketch profile, and if you off this neutral fiber and you try to create this thickness 1 mm, so it will go inside. So you can see this. So this thickness is 1 mm, and outside thickness, let's suppose it is 4. So outside of the sketch profile the thickness is 4. So this result you will get it if you use the thick option. But if you want to close solid, you can switch off this thickness, then click OK. So this is what about a pad tool. Now I'll save this file and close this window. Now next tool is pocket. So let us operate this command into the software. So click on start, mechanical design, part design. Here the command name is pocket. This is second number. Click on OK. hide these planes, insert axis system, create a first base profile using sketcher tool. I'm creating the base profile as a rectangle. This is 20. This is 12. I will add a base material to this base profile using pad tool. This height I'm taking here 5. Now again I'm going to create an offsetted plane, the distance of 35, and there as well I'm trying to create another profile for the next feature. So here again I'm creating here rectangular shape of profile, and this dimension is, this is 18, this is 10. Exit the workbench. Now again I will add a material to this second profile. Now to operate this command, which is pocket, I required a profile or the sketch to cut the material. So here I'm creating this profile, a closed circle, and this diameter is I'm considering here 10. And these 2 points I connect it with each other and then exit the workbench. Now here I want to cut this material with respect to this profile with the help of pocket tool. So the function of pocket is to cut the material along the direction of line. By default, the direction of material removal is perpendicular to sketch, or you can change the direction of metal cutting by providing here direction tools. So direction can be the linear, it can be perpendicular to the sketch, or it can be any linear direction. So here I'm selecting this pocket, click on the sketch, and if you see here the material will be removed from the downward side, whereas my direction should be reverse. So I just click on this reverse direction option and see this preview. The material will be cut like this. Based on the given depth dimension here, that much material is get only cutted. Here you can see, but I want to cut complete throughout, then you can use here up to next tool. And this cutting I required here for this as well, so it will be cut accordingly, but I need a specific feature only, then you can use here up to surface, and on only this surface I can able to select and see this preview. You need to use this up to plane and select this plane. We can see this preview here. You can see the material is cut up to this face only, but if you use here up to next, so all features are get cutted. Again, if you use here up to plane, you can able to select this plane. Up to that plane limit only material will be cutted, but there is no any uh, material to cut up to this plane reference. So instead of selecting this bottom plane, it is better to select this top plane. Now you can see this result. It will be cut the material. So the function of pocket is to cut the material. So with the help of that, I can able to create a hole using pocket tool as well. But that is not a good practice. There is a separate command to create an hole. So here I am creating a profile circle. The diameter of circle is 5, and now I exit this workbench and then create here hole with the help of tool pocket. Just click on pocket, select this profile, that is a sketch, and you can reverse this direction. And now here I require up to next feature surface. Then you can see the hole is cutted up to the next face. It will not cut over here. And to see the effect, I need to use up to last feature. Then it will cut the material up to the last surface. We can see this result. And here, if I use only up to next, only it will be cut for the first feature, and then click on OK. Then it will get the result. I need the pocket. If you reverse the direction using this reverse side option, then here the material will be cutted outside the sketch periphery. So it is this direction showing. If you reverse it, so the material will be cutted inside this profile, but I want to cut the material outside this profile, and I need to keep the material inside this profile, circular profile. Then you can reverse this side. So depend on side reversion, so the result will be displayed. You can see here generally the material will be cut inside the sketch periphery. By default it will be always inside cutting, but if you use this outside cutting, then result will be like this. And then click on OK. So this is the material removal tool, which is pocket. So let us talk about the next tool, which is shaft. So the shaft will add a material around an axis. So it will create the material around an axis. So especially it is used to create a circular object or cylindrical objects. So to do that, let us try to operating software. So just go to the start, click on mechanical design, part design. The third feature is a shaft. Then click on OK. Hide this plane. Go to the insert, create an axis system, current off. OK. Now I'm creating here a sketch profile for creating the base feature. So to create base feature, I'm selecting this front view, click on OK, and then draw this profile. So from this rotation axis, so while drawing this profile, very important part which I forgot to tell you, that you need to create a rotation axis inside the sketch. So this command will be applicable only for creating the shaft or groove kind of features. So I'm selecting this rotation axis and draw here one linear axis. From this axis I want to create the diameter. I just click this diameter, but it shows the radial form. Just hold a right click here, you will be finding this option. Either you can keep the dimension in radius or diametral form. So I'm selecting this diametral form, define this diameter to 150. Similarly, for another smaller diameter, I'm selecting this rotation axis first, then click this second line as the dimension line, and then hold right click here. You can see this option radius or diameter. You can convert into diameter form. So this will be happen only when if you provide the dimensions from the axis, which is this axis only. And again you can convert this into radial form by switching selecting the command. Again you can select this and select this. You can hold right click here, click on this diameter. This will show into diametrical format. Now I'm selecting this diameter, defining this diameter to 90. Okay, then this is a linear dimension. You cannot convert it into diameter because it is a line entity. So here I'm defining this value to 25. Then again this total height from this to this, I'm defining this value to 100. Now if you see here, the entire profile is converted into green, and you just check out before exiting the workbench using sketch solving status. It is showing to you it is under constraint status. So to resolve this, we need to find where it is under constraint. So this dot indicates the dimension is missing over here. So I'm going to create here the dimension, or else we can connect this point to this line by right click here and use this coincidence constraint. Now you can check the status. It's showing ISO constraint, which is fully constraint status. Now click on exit workbench and use the command, which is this, which is shaft. If you observe this toolbar, only few specific commands are active and others are deactive. That is because only material addition commands will showing the active mode. Once you create the material addition, then only metal cutting will be shown. So currently there is no any first metal addition tool or the features. So that's why here the other commands, material removing commands, are disabled. Once you add the first feature, then only it will be active. So you can select here shaft and select the sketch from this profile tool. So this is that shaft definition dialog box. Here as well, just like a pad, you will be finding two different limits, that is first limit and then second limit. So in the first limit you can define this angle to 360 degree, which is complete rotation, and define here sketch profile, which is this one, and see this preview. You can see the material is added like this. So angle of rotation is 360 degree. To see this effect, I'm changing the orientation to top view. You can see here this is 360. I'm defining this value to 245. See this preview and you can see this. So this is our sketch, and from this sketch the material is added up to 245 angle limit. You can rotate here. Now it is 270. Now see this preview. So material will be added here in anti-clockwise manner. So that is my first direction. If you use the second direction and you try to rotate this second limit, it will be added material around clockwise direction, along the clockwise direction. So here if you see this limit is 20. So first limit and second limit indicating clockwise and anti-clockwise direction of rotation. Now here you define the second limit 0, and my first limit I am considering here 360. Then accordingly the material will be added complete 360 rotation. Now to see the effect of rotation, I'm just intentionally defining this value to 270, and you can see this result in the 3D mode. You just slightly rotate this mouse, you will see this material is added. Now if you use this thick profile option and I define this thickness, that is 2, and you see this preview, the thickness will be provided. Because of the center line, the thickness will be applicable for the center line as well. If you go to this sketch and try to modify this line and convert this line into this reference using construction mode and try to exit this, you can see this line will be disappeared. Now my profile in the sketcher is open entity profile. It is not closed loop. You can check the status through here using sketch analysis tool, and you will finding here in the geometry tab the profile is opened. This profile is open, then you can only define in this situation the thick material addition. You cannot create close material addition. You can see here result, the thickness is a 2 or 3 mm. We can define it is always inside material thickness, and here we can define the outside material thickness, that is 2. So inside and outside you can define here. So accordingly you see this effect, small metal here, large metal here. So you can define this to 5 to see the better effect. I am defining this 5. Now you can see that if you use neutral fiber, again the thickness becomes symmetric. And now I'm switch off this button and go to the list, select here preview, and I don't want to create the thick profile. Try to switch off, it will show this error if the profile is not close. But currently the angle is we are considering the rotation axis at center, that's why it is considering the close profile. I'm defining this close profile through this sketcher tool. Again I just convert this construction entity into standard entity again using this option and then exit. Now you can see this effect. I think it is not done. I just do it one more time. You can select this, you can hold right click and you can select line object, not taking, I can select here. And now here is the situation for selecting the specific entity. So here the center line and standard entity both are overlapped. So how to select it? Go to this sketch solving status, select here sketch analysis tool, and here in the geometry, uh, yeah, here you will be finding here construction entities. So few entities are in construction mode, you can see that. So this is the axis, this is line number 6. Now here you can select this line and then convert it into uh, convert them into standard element, and then exit this workbench and see this preview. Now I'm defining this angle to 360. See this preview, click on OK. So this is what about the shaft. So using shaft you can add material around an axis. So the next tool is groove. So let us see it into the software. Click start, mechanical design, part design. Fourth command is a groove. Click on OK. Hide this planes, click on insert, click axis system, current off. Okay, now I'm selecting the base feature. So let us create a base feature which we did earlier. I create here rotation axis, define the diameter from here, this is 150, this is 90, this is 90, this is 25. Now click on exit and add the material first before material removing process. So I'm selecting here addition using revolve tool, 360-degree rotation axis as we discussed earlier. Now here I want to create a groove tool. So you can select here sketch, select the front plane, click on OK, create a profile, define the diameter here, this is 20, define the rotation axis, from this center point, and from this rotation axis only you need to define the diameter. that diameter I'm considering here 88, and then location of this groove from this horizontal reference I'm considering here 40, and then you define the groove profile in the sketch. You check the status, it should be ISO constraint. It's showing under constraint as we seen earlier. That is because of this construction center line axis constraint. So you define here coincidence constraint. Now exit this. Before doing exit, you just double click and just check one more time. It should be under constraint. Somewhere it is again issue. You can see that this center point is not constrained here as well. You need to make it constraint as a coincident. And you check the status, it is showing ISO constraint, and check the analysis in geometry tab, it is closed. Now click on exit and use the tool groove. Just click on the groove, expand the specification tree, and here dialog box of groove showing the all is related parameter. So groove angle are required here 180 degree only, and in 180 if you reverse this rotation you can see this result is 180. And then here the second angle I'm defining 60 degree. So accordingly material will be removed. If you click this value to 0 degree and this total angle is 360, here the 360 complete rotation you will get. So in the groove you can remove the material around an axis, whereas in shaft you can add the material around an axis. So this is about now I repeat one more time to explain more about groove. I just select this, and by default software recognize the rotation axis because I already drawn that rotation axis inside the sketch. But if you forgot to add it, then you can select it manually by using this manual selection Z axis. So you can see this rotation is considered, that rotation is considered. So here if you provide the thickness is, let's suppose it is 5, so 5 mm thick groove will be created. If you use neutral fiber on, it will be add material, sorry, it will be remove the material at specific thickness which is symmetrical distance. So the thickness is symmetrical because neutral fiber is on. So if you switch off it, then so first limit and second limit as per your defined parameter, it will be considered thickness. So I don't want to create the thickness right now, I can switch off and this groove will get created. So groove angle I'm defining as 60 degree, and you can see this preview. If you want symmetric value, both side you need to define the same values, 60 and 60, first limit and second angle limit, and accordingly you enter the values and click OK. So this is get created the groove. If you double click here, you can able to modify to 360, and here it shows the warning. That means that both one angle, if you provide one angle 360, another you cannot take specific angle. So here I'm defining this value to 0, and this preview, click on preview and click on OK. So this is about the groove. So based on the shape whatever you created, so that shape will be cutted around an axis. So in the quick overview, so first command we discuss about the pad. So pad will add material along the axis or along the linear sketch direction. So it will add material along the direction, whereas in pocket it will cut the material along the direction, and in shaft it will add a material around the direction, and in groove it will cut material around the direction. So I will save this file click on save this file and then close. So thank you for attending this session. We will see you into the next session.